Hello, welcome to Jet Mathematics. I remain your host, Milton Ebiwarijan. Today we are looking at simultaneous equation. Simultaneous equations. So we'll continue from where we stopped in our last class. So we will be doing today one linear equation and one quadratic equation. So that's the system of equation that we'll be solving today. So we have an example. Solve s plus y equals to 3 and s y equals to 2. So this equation is linear while this equation is quadratic. So it's very simple to solve problems like this. All you need to do is to make either of the unknown from the linear equation is the subject matter, and then substitute it into the um, second equation, which is the quadratic equation. So this is a quadratic equation, so we can solve this. We can say solution from, let's call this 1 and let's call this 2, equation 2. So we can say from 1 we have, so making s the subject matter from 1, we have s is equals to 3 minus y. 3 minus y. So when we take y this way, it becomes minus y. So next we need to do is to substitute this into equation 2. So substitute s equals to 3 minus y into equation what? Equation 2. Okay? Pretty easy. So we are going to recall equation 2. Equation 2 is sy equals to 2. So anywhere we see x there, we are going to plug in 3 minus y. So doing that, we'll have say 3 minus y bracket y is equals to 2. Pretty easy. We'll expand this. We'll get 3y minus y squared equals to 2. So we can take all of this term this way so that our y squared becomes a positive term. So when we take all of this here, we have y squared, y minus y squared crossing this way gives us y squared. 3y crossing this becomes minus 3y. And this is left here is plus 2. Then nothing is left here, so it's equals to 0. So that's the quadratic equation. We are going to solve this quadratic equation and then we'll be able to tell the values for our y and then for our x. So let's see that now. So solving this, we are going to factorize two numbers such that if you times them, you are going to get 2, and then if you add them, you are going to get minus 3. So those numbers are minus 1 and minus 2. If you are yet to know how to factorize quadratic expression, just see our videos on factorization of quadratic expression. So you can see we have y squared minus y minus 2y plus 2 is equals to 0. So grouping this, we have y, and here we have y minus 1, here we have again minus 2 factored out, then we have here left y minus 2 equals to 0. So this minus 1 rather, equals to 0. So this will have y minus 1, and then this and this forms y minus 2 equals to 0. So from here we can say y minus 1 is equals to 0, or y minus 2 is equals to 0. So here we say y is equals to 1, or y is equals to 2. So if y is equals to 1 and y is equals to 2, we'll substitute. Let's call this equation we generated the other time equation 3. So we're going to plug this result, substitute these results into 3. So we've gotten values for y, we need to get values for s. So it will be easy for us to substitute these values into this equation, and then we'll get our values for x. So we have when y is equals to 1 and when y is equals to 2. So we solve this, we have that x is equals to 3 minus y is now what? 1. So s is equals to 2. Or we can have it here, s equals to 3 minus 2. And so s is equals to 3 minus 2, 1. So we can conclude we have two sets of solution. Therefore, the solution could be s equals to 2 when y is equals to 1. So when we substitute this here, s equals to 2 plus y equals to 1 gives us 3. And then when we say 2 times 1, it also gives us 2. Perfect solution. Or we can have it as, for this case, s equal to 1 when y equals to 2. So it also satisfies when you put s1 plus y2 gives us 3. And when you also do 1 times 2, you also get 2. So these are the solution to this problem. And every quadratic this is supposed to be quadratic. Sorry about that. So this is how you solve every one linear, one quadratic simultaneous equation. Make the subject formula from the linear, substitute it into the quadratic, and then you simplify and get your results. Follow us in our next video as we solve more problems still on simultaneous equation. Bye.